Both my parents were very encouraging. Mathematics is part of life. But do you know how to prove it? I said, no, it is a set of infinite numbers.
Welcome to Scientifically Yours, a talk show on Indian women scientists who have made us proud, who have made significant contributions in the various areas of scientific research, both nationally and internationally. Today we have with us Dr. Riddhi Shah, an eminent mathematician. How do you recollect your childhood memories, ma'am? Let's share with us some.
I was very happy as a child, and I was one of five children of my parents, and I have an elder brother, and then it was me. And as you may know, I really loved walking down the street and going to school, but then it got very boring after a while, so I would go slowly, and then my teacher would scold me every day, until one day she was waiting for me eagerly, and it was my maths result that made her happy. And since then I went punctually to school every day except on the day of the result. I was extra late on that day.
So you were studying mathematics right from the beginning. How does your interest in mathematics grow?
For me, it was only mathematics that interested me. Other subjects were okay as long as there was some mathematics in it. And I liked to play with numbers. When I was younger, I would think about prime numbers, and I would think about bigger and bigger numbers which were primes. And then I thought about once fractions, and I observed some simple rule about fractions, and I would apply it whenever I could. I was in high school then. And then my school principal sent me to the Vice Chancellor, Professor P.C. Vaidya of Gujarat University, and I went and talked to him about it. And he told me that it is true, but do you know how to prove it? I said, no, it is a set of infinite numbers. How do I prove it for an infinite set of numbers? Then he took a chalk and he went to the blackboard in his office, and he just demonstrated a proof which was just 3 lines proof, very simple. And that is what excited me about mathematics, that you can prove something about infinite numbers.
So that was your kind of a turning point and a decision-making factor to pursue mathematics.
That is when I decided to do
mathematics,
though I didn't really know what mathematics research meant at that point.
Who has been your role model in family, and besides family members, who has been a source of inspiration to pursue mathematics and a longer career?
So both my parents were very encouraging. My father was an engineer, but he was very good at mathematics, and that is what excited me. And he was kind of a role model in the family, and when I was very young, I thought mathematics means engineering, and I would do engineering like my father. But my mother always said that I should do a PhD in mathematics, as I loved mathematics. And then later in college, I had a teacher called Shanti Prasanna, and she was really encouraging. And then later on, I had this PhD advisor, Professor Dani from TIFR, and he was very gentle, and he explained to me and taught me a lot of basic
So after your graduation from Ahmedabad, you went to TIFR for your higher studies, for your PhD?
First I went to Indian Institute of Technology, Mumbai, and for 2 years masters. And then I went to Tata Institute of Fundamental Research.
As we all know that mathematics is the language of science, you take any subject that is the basis of modern science, biology, physics, chemistry, bioinformatics, even astronomy. economics, even many branches of humanities where maths plays a major role. When we say that it's a tool for all the subject, how do you react to it?
Well, mathematics is part of life. Where at every mode of life you need mathematics, whether it's counting numbers or you're doing some online transactions or you're analyzing data or you are studying some graphs for a particular behavior pattern, whether it's about cell behavior or human behavior or statistical population growth, environmental science. But when I looked at mathematics and started doing it, for me it was just mathematics. I did not think about it as a subject.
But could you correlate it with the basic life, the real life situations, how the mathematics play? As you were mentioning, it is there in everyday life. So how could you really relate it?
Actually, you know, when mathematicians do mathematics, they do it as an abstract subject because they love mathematics, and more abstract the better. And then when they see some applications, like today you do credit card transactions, you do online payments and so on, the idea, the mathematics behind it is very simple. It's called clockwork mathematics of prime numbers. And when mathematicians studied that many years ago, there were no computers, there were no online transactions, and they had no idea that this is what is going to be the key use of that. They were just doing it as, you know, they loved numbers and playing with numbers, and they were just studying properties of prime numbers.
We'll take a short break now. Don't go anywhere. We'll be back in a moment.
कैसे हुआ आसमान नीला,
पानी को कौन करता गीला,
ये धरती क्यों है गोल,
हमारे जीवन में सूरज का क्या है रोल, हवाई जहाज हवा में कैसे उड़ जाता,
पूरी को कौन है बुलाता,
कौन भरता इंटरनेट में इंफॉर्मेशन,
क्या कभी हवा भी होगी रेशन।
सोचोगे नहीं तो पता कैसे चलेगा? विज्ञान प्रसार, ताकि हर निर्णय ज्ञान आधारित हो। Vigyan Prasar, 850 Institutional Area, Sector 62, Noida. Email info@vigyanprasar.gov.in. Website www.vigyanprasar.gov.in.
Welcome back to Scientifically Yours. We are talking with Dr. Riddhi Shah. Welcome, ma'am. We were talking about you have been doing major work in dynamics of group actions, structure of groups and probability groups. What exactly do we mean by these areas of work? If you could explain in simpler terms to the viewers.
Group actions or groups are basically about studying symmetries. Symmetries of objects, symmetry of transfer. For example, if you are standing in a field and looking all around, then if it's a very large field, it looks just the same everywhere, all green, you know, with the grass. So this is called rotational symmetry. For example, if you have a circle and or a disc and you move it around, then it just looks like a disc. When you turn around, it doesn't make any change. In the, so So these are the symmetries, and there are many inherent symmetries in crystals and many parts of life you may observe symmetry. And dynamics is something which is study of anything which moves with time. So whether it's a butterfly flying and when its wing makes a difference with air current, or rather the air current affects the flying of a butterfly.
So mathematics in nature actually.
Yeah,
so much of
so dynamics is about study of these, and it could also be about study of chemical reactions. It could also be study about how the cell grows. So what dynamics I do is more abstract than that, but some of it could have applications in future.
Have they been actually tried out in applications, like you mentioned about birds' wings or even space or a chemical solution? These behavioral patterns, have they been studied using these symmetries? And
Yeah, so they have been studying, in fact, how neurons behave in brain, human brain. People have dynamic model, the model of a dynamical system. It's actually a differential equation which gives these patterns of how neurons behave. But what I do is much more abstract, and I work in pure mathematics. I started with what is called probabilities on groups. Everybody knows what probability is. You study, you have probability in how the market behaves. And so probability simply means what is the possibility of an event.
chances.
Chance. Probability means chance. So what is the possibility of something happening? It's also partly like a random walk. You say that how a particle is moving and where it would end up after some time. You want to predict where it would be. For example, you are walking in a field and you are taking steps randomly. It's called random variable. So you're taking steps randomly, and after some time, like say time t, where would you be in a field?
Somehow we find that till now the children run away from mathematics. There's a fear in studying maths, but there are a lot of efforts that is being going on, to generate interest in maths and also to sustain the interest in maths, because there's always a phobia I've seen that's an average children have it. But as a mathematician, how do you look at this, that how can we really create interest in mathematics?
I think it's a myth created by sometimes teachers, sometimes other peer groups, that mathematics is difficult. I would think mathematics is the simplest subject in school, not just because I love mathematics. You see, it's very logical. It just follows a set of rules. Mathematics is an exact science. There is no, approximation, ambiguity in it, and it's the easiest thing to do. And I think one should just try to get rid of this myth and try to encourage students to take up. And as for the higher research, for mathematics you need only pen and paper, sometimes not even that. You can do it in your head. So you don't need much resources for it. You need maybe library, but then nowadays there are a lot of online resources available. So it needs very little of your resources, very little time, in a sense that you can do it anywhere.
But it is generally observed that lesser women choose mathematics and physics. What is the reason for that? Is it the analytical approach of the subject that make women to opt out from studying physics and mathematics as compared to biology?
Yeah, actually I'm surprised by this phenomena. Actually, you do need much less time to do mathematics, and why women do not take it up. But my feeling is that a lot of people who are good at maths and might consider doing mathematics often end up going into engineering or financial mathematics. As you see in IITs, there are a lot of girl students in engineering departments. So I think that may be one of the factors why
they go to the application rather than the pure mathematics, the research.
Yeah, but I would like to say that you must do pure mathematics because you have to have a sound base. If you have a sound base, then you can do applications more easily. As I gave you an example earlier about use of prime numbers in these internet transactions, and that could not have happened if people were not playing with numbers. And it is all very good to say that everything should be applicable and you only should work in interdisciplinary and applied mathematics, but I do not think that applied mathematics can progress much more without having pure mathematics, progress in pure mathematics.
With that, we take a break. We'll come back again. Don't go away anywhere.
कैसे हुआ आसमान नीला,
पानी को कौन करता गीला, ये धरती क्यों है गोल, हमारे जीवन में सूरज का क्या है रोल, हवाई जहाज हवा में कैसे उड़ जाता,
पूरी को कौन है बुलाता,
कौन भरता इंटरनेट में इंफॉर्मेशन,
क्या कभी हवा भी होगी रेशन।
सोचोगे नहीं तो पता कैसे चलेगा विज्ञान प्रसार, ताकि हर निर्णय ज्ञान आधारित हो। Vigyan Prasar, 850 Institutional Area, Sector 62, Noida. Email info@vigyanprasar.gov.in. Website www.vigyanprasar.gov.in.
Let scientific temper be the basis for building nation.
Welcome back to Scientifically Yours. Today we have with us Dr. Riddhi Shah, mathematician teaching in JNU, New Delhi. Now we talk about the teaching mathematics in university and higher education. You have taught in TIFR, you are teaching in JNU, and also you were there in University of Florida, USA. Did you find any difference in the education system, and especially in mathematics research and education, and what is the children's level of intellectual as far as mathematics is concerned?
So I taught a few courses in TIFR at PhD level and master's level. There is not that much teaching in TIFR because it's a research institute. And during my stay in TIFR, I went to University of South Florida for a semester and taught courses to undergraduate students there. And the students there were also very enthusiastic, and they were very focused, and there were many Indian students there, many girl students there. And I have been to many places like Göttingen, University of Dortmund, Hebrew University of Jerusalem, and Keio University in near Tokyo in Japan for a postdoctoral fellowship, but I haven't taught there. It was for international collaboration, and though I have taught in many workshops in India and abroad about what I work on namely dynamics of distal group actions currently.
What kind of collaborative research going on between India and other countries in the world in the field of mathematics, ma'am, pure mathematics?
So, as far as I know, it is mostly on a personal level.
These are all university institutional collaborations at the university level.
Some universities and institutes do have memorandum of understanding, what are called MOUs. But as far as I am concerned, I am usually doing personal collaborations in mathematics, but I was fortunate enough to get 2 fellowships. One was Alexander von Humboldt Stiftung postdoctoral fellowship, and another one was Japan Society of Promotion of Science, JSPS Invitation Fellowship for Senior Scientists, which had sponsored my visits.
So you got the opportunity to interact with the foreign students and faculty and teach and do research.
Yeah.
And you have been awarded with a number of awards. You've been awarded the INSA Young Scientist Award. How do you feel? Like, do these recognitions really boost you to achieve the newer heights, to attain success in life?
Well, it's good to be recognized, and it does boost your confidence, and you feel that you want to do more and more.
Being a woman, we often encounter social and challenges and professional challenges. How do you react to this?
I was fortunate enough to have support of my family, my parents, my husband, my in-laws. They were very understanding. You see, I spent 14 years apart from my husband. I was in Tata Institute while he was at Harishchandra Research Institute, but none of these people ever forced me to leave my job and my work and go stay with my husband. They were very supportive. There were some distant relatives who had objections. They said, you know, your place is with your husband. You can surely find a school job or college in Allahabad and teach there. Why are you here? You should first think of your marriage, family, your son, and then. But my immediate family was very supportive.
There are a number of issues addressing the women in science, like women are seen in science, but after a certain level, we don't find many women in the leadership positions or at the level of decision making. So what is your opinion in that? That how do we bring in more women in science at a top level so that it helps in national building and nation building?
I would think that traditionally the professional bodies are made from men because there were more men, and there are still more men working in science and scientific bodies. So I think men usually do a lot of collaborations and networking. That's the word I was looking for. And I would think that if they consciously look for a woman who is equally competent or even more, very often they would find. So they should look for any given position. If they are looking for men, they should also look for a woman and try to hire or try to put them in these professional bodies, and that may slowly change the scenario. The other thing is that women look naturally more for, you know, career and home front
They have
together.
to do
They
the
want to-
work-life balance also. They have to manage that.
Yeah, so they are not so bothered about these professional bodies. They are not so bothered about being in a higher position. They want to do good work.
How do you see the future of science in India particularly?
Nowadays, I find that slowly the trend is changing. There are more and more people, more and more women doing science. And though I do not see so much change in mathematics as yet, but slowly I find that people still do PhD. After that they leave and they go away and do different things because they think doing research takes a lot of time and they want easy career.
What is your message to the younger generation, ma'am?
My message to younger generation is that they should take up a career in science, especially in mathematics, as it requires very little resources, and there are lots of opportunity. There are lots of jobs and positions available at universities, at these research institutes, where they can get a job. Actually, there is a scarcity of mathematicians, and we always struggle to hire them. So I think they should try this out, and the satisfaction they will get from doing mathematics, because you can do it quite independently once you are trained.
Thank you so much, ma'am. It was fascinating interacting with you. With that, we have come to the end of Scientifically Yours. Stay with us. We'll be back in the next week with another scientist in another episode.